Hello everybody and welcome to episode 14. In episode 13 we added our attack animation, and in today's episode we're gonna start working on the actual hit detection for this attack, so we can tell if it's collided with any type of entity, and then from there we can do whatever we want to those entities. In this episode I'm just gonna make them turn red to indicate that we've hit them as a temporary thing, as most of today's episode is just going to be focused on actually finding what entities have collided with the hitbox of our attack. So the first thing I want to do is establish what the hitbox for our attack actually is. And this is kind of one of the biggest parts of making any type of melee attack system, is how do you handle your hitboxes. A lot of different ways to do this. I'm going to go with one that's not necessarily the most efficient, but is one of the absolute easiest to manage and is one of my personal favorite methods of dealing with this. You'll already be familiar with it if you've watched my melee attacks tutorial. It's exactly the same. Okay, so first of all, let me show you our hitbox sprite that I'm going to bring in. So I'm going to go to sprites, create a sprite, name it after our attack, player attack slash, and then put the letters HB on the end to indicate that it's the hitbox for that attack. And then I'm going to hit import and find the one with the appropriate name, which is player attack slash HB underscore strip 16 if you're using my assets. Okay, bring that in, and you'll see now when I hit play, this is just a bunch of red boxes and rectangles just sort of flickering all over the place. They actually line up with where I would want the collisions to be on this sprite. You'll notice it's the same size sprite, and you can see roughly in the same sort of position as these slashes end up. You might be wondering, how did I actually make this hitbox? It's a little harder to tell when we're in this project. So I'm just going to briefly pop over to the pre-production code project and show you just exactly how I made this. So here we are in the pre-production code. This, as you can see, has got a lot more sort of assets and stuff to it than our current project. This is everything that we're going to make and have yet to make. The reason I came in here is I just want to find, where is it in player, player attack slash HB. Oh, and I've already got it visible, actually, interesting. So I've got to edit image. I untick this layer, you can see it's the same thing I just imported. The way I made this was I literally made a copy of player attack slash, so it just had the cat in it doing its animation, and then made a second layer, and on that layer I simply drew a red transparent box over where I wanted the collision to be with our attack. Okay, so what part of the attacks I want to consider, damaging to an enemy or an entity, right? And then all I had to do was literally on this other layer, just turn this layer off, and I'm left with just those hitboxes. So that's how I built this. Very, very easy way to just build that. And obviously, because I'm just copying it across to the other project, I've kind of lost that layer. But when you make this for yourself inside your own project, if you're doing it with your own assets and artwork, is keeping this layer around, even though when you've marked it invisible, it's obviously never going to show up in the game. Keeping that layer around is very helpful, just to be able to make any changes you need to the hitboxes at any time you want. Okay, so here we are back in our main project. The things I'll need to do to this sprite, just to set it up fully, is make sure the origin matches the origin of player attack slash, which is 3823 in this case. 23, that's up here, moves that cross to be around down there. Then in collision mask, I want to go to where it says type here, I want to go to precise per frame, with slow in brackets next to it. Okay, the reason for this is that gives us, it's the only setting that actually gives us a different collision mask. You see the sort of the dark box that's kind of covered up this now. It's the only one that gives us a collision mask per frame, and then automatic is because they're all just simple rectangles of one set opacity. It's easy enough for it to find the bounding box of each one of those, but it's the only setting that gives us a collision box per frame, since each one is different, right? Each one's a different stage of the attack. As I said, this animation, it lines up exactly with so if we go to like frame 2 there and frame 2 there, you can see it lines up exactly with our attack sprite, because that's what we used to make it. So basically what we then do is we use this as a mask to check for collisions when this animation is playing, and that's how we manage our hitboxes. So you might be worried or have questions about, precise per frame, because it has slow in brackets here, and be like, well, is this going to slow down my game? Is that a really bad thing to use? And the answer is no, not really. Fairly trivial to use it here because it's literally one sprite that we're going to be using to collide with a bunch of entities that are just using regular bounding boxes. But with that said, that's not a green light for you to go ahead and put precise per frame on like all of your sprites for all of your collisions going forward. Generally, like if you want a rule of thumb for this kind of thing, right, is if you know you're doing something like this for a specific reason, such as this, we needed a collision per frame because it was a solution for a problem that we don't necessarily know otherwise how to solve in a faster or more effective way, then it's a good idea. If you are doing it and you're not necessarily sure why, but you figure precise sounds good, I want my collisions to be precise. Of course I do. Let's tick precise. Don't do it, okay? It's the type of thing when you're working with anything that's slow. Obviously, those things exist for a reason. Those things are there to be used, even if there are often like better or faster ways of doing those particular tasks. But you don't. You want to use them sparingly, and you use them when you know exactly why you want to use them, okay? And in this situation, I know exactly why we want to use this, so you can go ahead and trust me in that I'm telling you that now is a decent time to use this. But if you don't know exactly why you're using it, generally avoid things that have slow in brackets in them, and avoid things in the manual that warn you that they are slow, and so on. Unless, as I say, it's a solution to a problem you have that you don't otherwise know how to solve, then go for it, because chances are a lot of the time you'll find it doesn't slow things down as much as you think, and the only time you have to worry about things slowing your game down is when they actually start to slow your game down. When you've got tons of these tons of things doing precise per frame every step, and your game starts to struggle as a result. That's you worry about optimizing for efficiency when you start to have efficiency problems, is generally the rule of thumb for that kind of thing. Alright, so moving on, just make a new workspace just to quickly close all that stuff down. I'm going to open up OPlayer, and I'm going to establish a variable in here quickly, just up here where we've got the attack stuff, I guess, because it's relevant to that. Hit by attack is going to equal -1. This is a variable in which we're going to store a DS list, a data structure full of entity IDs or instance IDs of our entities that have been hit by a particular attack. This is what's going to allow us to do an attack without it like hitting something every single frame that there is a hitbox over it, because chances are these frames, depending on how fast they're playing and so on, they may be on the screen for more than one step, and if they hit something and say deal damage to it, we don't want them dealing that damage every single frame that the hitbox overlaps. Okay, we just want to do it once until the attack completes. There is freedom in this setup for you to think about how to rewrite your attacks and stuff, since we've got this modularity for doing multiple types of attacks, to be able to write attacks that then they deal damage once, but then clear. Say you've got like an attack animation that does 2 swings, and you want each one to be able to do a hit. All right, you could write something into the attack that says, "Oh, once you've hit frame 12, clear that list," and then you'll be able to hit everything again. Anyway, that's the point of this variable. We're going to store a list in it of everything we've hit so that we don't hit them again, and then we can manage that however we want to. All right, with that done, there's nothing else we need to add to the player. I'm going to come into attack / quickly, just our /attack function. I'm going to make some changes up here where we establish if we have just started this attack, we set up our animation appropriately. If we do that and we know we've just started the attack, we also want to clear the hit by attack list if it is not already cleared. This is to make sure anything left over from our previous attack goes away. Alright, so I'm just going to comment it. In fact, this is badly commented generally, so let's just write attack just started at the top here. Set up animation. We'll say correct animation, so we know we're going to the right one. And clear hit list, because that's what we're going to do here. So I'm going to type if not ds exists. Okay, it's a function that will just look for a data structure in a variable, and if it exists, it'll come back true, otherwise false. Hit by attack, and you can see at the bottom we also need to provide what type of ds list, what type of data structure we're looking for. So that would be ds underscore type underscore list, close bracket, close bracket. And if that's not true, so if there is nothing in hit by attack, say this is the first time we're doing this attack, then we need to make it, because at the moment hit by attack will just be -1. So hit by attack equals ds underscore list underscore creates. Alright, so if there's no list, we need to actually make that list. This is why we're doing it at the start as well, rather than the end, because we need to actually make the list if it never existed in the first place. Next up, we're just going to write ds underscore list underscore clear hit by attack. Alright, so if the list does exist, and well, we've made sure it exists here, we empty it here, so it's got nothing in it, and we know that every entity is now available to be added to the list and hit by our attack. Okay, now we've done that, we're going to make a new function entirely, and I believe I talked a bit about this in the last episode. I'm going to call this calc attack, actually, just to separate it from our attack scripts that are different types of attack. And this function is just going to be used to do our hit detection, all right, because that's likely to be the same across our different attacks, right? We're just going to send over a certain hitbox and check to see what is in that hitbox and hit it, right? Using our hit list to tell us what has already and has not already been hit. As I said, if you want to, at certain parts of your attack, say this had like multiple swings in it, you could say something in here that was like if frame equals, if image index equals like 7 for the first time, or is greater than 7 for the first time, clear, just do this again, just do ds list clear hit by attack, and then you can have multiple hits in one attack. But that's the sort of stuff you would do in the specific attack function. This function is just about hit detection, okay? And just to show you, this is exactly where I'm going to call it in here. So I'm going to write it in here, calc attack, open brackets, and then the only argument we're going to pass through to this function is going to be the hitbox that we want to use, and as you remember, that is called s player attack slash hb. Let's sort of group these together. S player attack slash hb, close bracket, semicolon. That's the only thing we want to pass through this function. So in this function now, I can describe this at the top. Use attack hitbox and check for hits. That's what we're going to do. So this is all running from our player object, you'll remember. So I can change our player's collision mask by typing mask underscore index equals argument 0, so that hitbox we just passed across becomes our new collision mask. And then underneath this, I'm going to write mask index equals s player for the end of the script, right? So we're going to temporarily set our collision mask to be s player attack slash hb, perform our collision detection, and then set our mask index back to s player again. All right. Okay, so we're going to use a another ds list in this, as well as just hit by attack. We're going to have var hit by attack now, which is going to equal ds list create. That's just going to contain a list of all entities hit by the attack this frame, so that we can then compare that to things that have already been hit by the attack, and so on, right? And we're going to immediately populate that list by writing var hits, which is just going to tell us the number of entities hit this frame, so which is helpful because it'll let us know how many entities we have to cycle through and check. Hits is going to equal instance underscore place underscore list. This is one of the new GameMaker Studio 2 collision list functions that not only just tells us whether or not we've collided, but actually returns a list of all the entities involved in a particular collision. All right. So the collision we want to take place at the X and Y of our player, right? The type of object we're looking to collide with is P entity. The DS list we want to fill with the IDs of all the instances we've collided with is hit by attack now. And ordered, you see at the here bottom here, ordered is a Boolean, so a true or a false, that will basically, if we set this to true, it will order this DS list of IDs closest to furthest, all right, in terms of collision. So that can be helpful for various other different things. You know, if it's important to you to know which object was closest to a particular collision, that might be the only reason you're doing the list, because you might overlap, but you always want to get the closest collision. Then you can set that to true. But for here, we don't care, right? We don't care about the order or how close everything is. We just want to know what we've collided with and cycle through them. So we'll put that to false. Let's just save us a little bit of time. Then if hits greater than 0, which means, you know, we've found something. All right, we found something in that collision. If hits are greater than 0, then we want to do a for loop and go through each one of them. So for var I equals 0, I less than hits, I plus plus, I just being our trusty iterator that, you know, we always use with for loops to go through a list of things. So just to comment this, if this instance has not, I can't type today, oh my god, has not yet been hit by this attack, hit it. So var hit ID equals hit by attack now, open square bracket, vertical pipe I, close bracket. If you don't know where that is on your keyboard and you're wondering what on earth I've just done here, this is a special way to reference a particular entry of a DS list, basically treating it the same way you would an array, right? Just by putting this here, you can just refer to a entry number and it will just return that that slot of the DS list. Very, very useful. So that allows us to cycle using I from 0 to however many things we've hit, which is however big the list will actually be, right? If you don't know where this is on your keyboard, or if you just find that confusing, you can also use DS list find value, I think. Yeah. I so very rarely use these, I'm not even sure, but yeah, so this is correct. Hit by attack now, and then position I. So that would be, I think, the same as that. But I'm so used to using these this particular style of referencing that I just never use these functions anymore. Okay, so we've got the instance ID now of something that has been hit by our hitbox. Okay, okay, so now stored in hit ID, we have the instance ID of something that has been hit by our collision mask. Okay, so what we want to do with that is check to see if it is in the DS list of things we've hit so far with the entire attack animation, i.e. hit by attack. So I'm going to type if DS list underscore find index, the more useful of the two functions, hit by attack hit ID equals -1, close bracket. So what DS list find index does is it's going to go through this DS list that we've just provided it and look, basically it'll iterate through the whole thing and try and find this value, all right, which hit ID is, you know, the instance that we've just hit. So it's going to try and find that instance ID in our hit by attack list. If it can find it, it will return the index of it, so it will return like what slot in the list that's in. And if it can't find it, which is what we're interested in, it'll return -1. Alright, so if it returns -1, we know that this instance is not in our hit by attack list yet. Okay, so it means we haven't hit it with this attack. So if that's the case, then we want to add, first of all, this entity to that list. So ds list add hit by attack hit ID. Alright, and that'll just take that instance ID and stick it in that DS list, so that in future, if we were to hit it again and we were to run through this again, we would find that instance, run this, and it would not return -1 because it would be in the list, so it stops us hitting it again. Alright, but now we're in here, we know that we have hit this thing, so we can do whatever we want to it, simply by typing with hit ID. And then in here is where we will do whatever we want to do to the object that we've hit with the attack. In this case, and for this episode, I'm going to leave a bit of space, just because, you know, there is more stuff that's going to come in here. But I'm just going to, for now, write image blend equals C red. So we'll just turn the object red if we've hit it. All right, just so we can visually see it working in the game. Eventually we'll put like a little flash on things, and by default anyway, and we'll have different ways that different entities can react to being hit. Basically they'll have their own functions they can call, and we'll be like, well, with hit ID, if entity hit script is -1, then execute the hit script kind of thing, you know. That's how we will do it. Or we'll say if that object is an enemy, then hurt the enemy, and so on, right? But for now, we're just going to set it to blend C red. That's actually everything. So if I just tie this up there, or it's everything here anyway. The last thing we want to do before setting our mask back to be S player is simply to destroy the extra DS list we made on this frame. So DS list destroy hit by attack now. All right. Just leave that. Just remove that from memory. And we'll create it again on the next time we run through this. Okay, that's it. As you can see, we've already put it into place in attack slash. There's calc attack in here, passing through the one thing. Why has this got an error? Hopefully that's just something that, yeah, I control S and it goes away. That's something that just hadn't updated. And now I can hopefully just go ahead and run the game. Trying to think if I've forgotten anything, but I don't think I have. If I do the slash, yeah, you can see. If I just do it just out of range here as well, because it is a precise hitbox, so we should see like that's not hitting that signpost, but if I get close enough, there we go, just overlaps, the signpost turns red. Same with this one. Boom. So that's hit detection. That's hit detection for our attacks. I figured I would just carry it. It can be a little complex to get your head around, so I figured I would just cover that in this episode, and then we will deal actually with, you know, affecting stuff with the attack a bit later once it's had some chance to sink in. But it's fairly straightforward. It's just using a couple of DS lists to make sure you don't over attack things, and has been made a lot simpler in GameMaker Studio 2 now just because of the existence of this instance place list and all the list collision functions. Shout outs to Yellow Afterlife, who I believe did a lot of work with Yo-Yo on implementing these. Very, very cool. And yeah, that's everything for this episode. Thanks for watching. I'll catch you all next time. Huge shout out to all of my Patreon supporters, without whom I couldn't make this work. Thank you in particular, and in no particular order, to the following cool kids: Bowser the Dog, Zenan May, Robert Churches, Rovan Darlin, Zephyr Flame, Dakadondago, Max M, Bertie T, Relentless Rex, Do Want Doobie, T Lesson, Jason, James Siggins, Dark Rider 0318, James L. Anderson, Hare, Hyungjin, Rupinder, Renee Dam, Scott Matthews, Leo, Tyler Hubble, Maria Celeste de Oliveira Frailing, Cabbage Pants, Gilberto Cisneros, Figgy, Mark Burgess, John Harwood, Zach Collett, Goose, Caleb Franklin, Troy Mera, Alex Schenkel, Wilfredo Landera, Carter Green, Justin Edega, Julian Paul, and Kaiser Ho. Thank you all ever so much. Thank you for watching. Catch you all next time.